Assalamualaikum, salam sejahtera. Let's continue our lecture by chapter 2. The topic is kinematics of linear motion. Three subtopics here, which is 2.1 linear motion, 2.2 uniformly accelerated motion, and 2.3 projectile motion. Okay, the time suggested here is 1 hour and 30 minutes. For subtopic 1, which is under linear motion, students should be able to define instantaneous velocity, average velocity, and uniform velocity. Also, instantaneous acceleration, average acceleration, and uniform acceleration. Students should be able to discuss the physical meaning of displacement against time, velocity against time, and acceleration against time graph. Students also should be able to determine the distance travel, displacement, velocity, and acceleration from appropriate graph. Three different items used here for velocity and acceleration, which is instantaneous velocity, average velocity, uniform velocity. Still the same for the acceleration. We are discussing about instantaneous acceleration, average acceleration, and uniform acceleration. So what is the difference between instantaneous, average, and uniform? We need to understand this very well. Okay, so let's start by the instantaneous velocity. Okay, what does it mean by the instantaneous velocity? Or the symbol is V instant. Velocity at a specified position or instant of time along the path of motion. The keyword is here, at specified position or instant of time. Okay, commonly referred as velocity at point A or velocity at time t, at particular time. So the equation is V instant equals to limit delta t approaches 0, delta s over delta t. So seems like there is no changes in time. We are referring to particular time, so that delta t is still constant, no changes in time. So that the equation is ds over dt. Okay, d means that we just refer to one point only, which is at particular time or at specified position. Okay, next, the average velocity. What is that? Average velocity, the symbol is V average, is the rate of change of displacement, or the equation is V average equals to change in displacement divided by time taken for the change. Okay, so the equation just be like this, which is delta s over delta t. So delta s is the change in displacement and delta t is the time taken for the change. Alright, or delta s still equals to s2 minus s1 or s final minus s initial, and delta t is t2 minus t1 or t final minus t initial. Alright, so this is the difference between instantaneous velocity and average velocity. So you may refer to the link given here. I think by referring to the video, you may understand it very well. Okay, and then the velocity is a vector quantity. So remember, we are discussing about magnitude, also direction. And the SI unit of velocity is meter per second. Next, what does it mean by the uniform velocity? Uniform velocity means the velocity which is not changing either in magnitude or in direction, where the displacement changes at a uniform rate. S against t plot is a straight line whose gradient is equals to velocity. So for any uniform velocity case, by giving you a graph which is s against t, and the graph is under a straight line graph. So remember, the gradient now representing velocity. As we know, the equation of velocity is ds over dt, or s over t, which is constant here. Okay, so according to the situation, we may see that the gradient still remain constant, okay, at any position. That is why we are discussing about constant velocity. No changes in direction, also no changes in magnitude. Okay, next we just continue by the instantaneous acceleration. Instantaneous acceleration is the acceleration at a particular instant of time. Again, the keyword is at particular instant of time. Okay, then the question is limit delta t approaches 0, delta v over delta t. Again, at particular time there is no changes in time, so delta t approaches 0, so that the equation is dv over dt, and dv over dt still equals to ds squared over dt squared. So by having s equation, we need to differentiate the equation 2 times, and then you will get v. You will get a. By having s, for the first differentiation, you will get v, and then for the second differentiation, you will get a. So this is a, instantaneous acceleration. Next, the average acceleration. What is that? Average acceleration is the change in velocity divided by the time taken to make the change, or the equation is average acceleration is change in velocity divided by times to make the change, or delta v over delta t. Okay, still the same. Delta v is v2 minus v1, or v final minus v initial, and delta t is t final minus t initial, or t2 minus t1. Okay, the acceleration is a vector quantity, still the same. We are discussing about the magnitude and direction, and the SI unit of acceleration is meter per second squared. Then, what is the meaning of uniform acceleration? Uniform acceleration means the acceleration does not depend on time or always constant. Okay, means that the velocity changes now at a uniform rate. So by giving you a v against t graph, okay, which is under a straight line graph, the gradient now representing acceleration. Alright, acceleration equals to dv over dt, and for this case, we know that the acceleration is constant, which is uniform. So by giving you a graph which is v against t, the gradient here representing acceleration. So at any position, the gradient still the same. That is why we are talking about uniform acceleration. Velocity is a vector quantity, so a change in velocity may thus involve either or both magnitude and direction. And acceleration may due to change in speed, okay, the magnitude of velocity, change in direction of velocity, or change in both magnitude and direction of velocity. Okay, how do we get the acceleration actually? So it depends on three different situations. By having changes in speed, okay, we are talking about the acceleration. Or maybe by having constant speed, but we are talking about changes in direction, also giving you acceleration. Okay, and for the last case, by having changes in both magnitude and direction, also producing acceleration. Okay, so this is the quick test given. A car is traveling at 30 km per hour to the north. Then it turns to the west without changing its speed. Is the car accelerating? Alright, so now we just refer to the info given. Okay, without changing its speed means that the magnitude is constant. But now from north, the direction already changed to be west. So by having changes in direction, okay, we are talking about the acceleration, isn't it? Alright, so the answer is yes. Reason, there is a change in direction. And then next, what does it mean by deceleration? Deceleration of an object is a situation where the object is slowing down, where the direction of acceleration is opposite to the direction of the motion or velocity. So the keyword now is direction of acceleration is opposite to the direction of motion. That is why the object is slowing down. Alright, so this is the example. The object is moving to the right, but now the acceleration is directed to the left. Make it slower lah. Alright, so this is our deceleration situation where the object is slowing down. Okay, by giving you 4 different situations, which is A, B, C, and D. According to this figure, we may conclude that A and D is under acceleration. How do we know? According to the direction of A, acceleration and motion, they are in the same direction, isn't it? So in the same direction, of course, the object just accelerate. While for B and C, the direction of A and V just in opposite direction. Okay, so that they are under deceleration. So as conclusion, okay, car in figure A and D just accelerate, while car in figure B and C just decelerate. And remember, for any linear motion case, positive and negative sign is used to indicate direction of motion. And for velocity also, the acceleration. So for any vector, remember, we need to check the direction. Normally, for any object for any vector which is directed to the right, we take it as positive. Directed to the left, we take it as negative. For vertical axis, upward we take it as positive, and downward we take it as negative. Alright, for example, okay, displacement also under vector. So this is our origin. Okay, so at the origin the displacement is 0 lah. But now the object is moving to the right, and the displacement is 3. So that to the right, we know that the vector is positive. For the next case, the object is moving to the left. So this is the displacement, which is 4, negative representing direction. Okay, how about the velocity? Okay, for the velocity, still the same. Okay, because velocity also under vector. When the object is moving to the right, okay, the velocity is positive. When the object is moving to the left, the velocity is negative. And still the same for the third and for the fourth case given here. As long as the object is at the negative axis, but the motion is directed to the right, so that the velocity is positive. Okay, also for the last case given here, the object still at the negative axis, but the motion is to the left. So to the left, the vector is negative. So the velocity is negative. Okay, now just take a look. The table given here is all about the velocity and acceleration. For the first row, the velocity is directed to the right. So we know that the velocity is positive. But now, please refer to the magnitude. Remember, the length of the vector now representing its magnitude, isn't it? So the length just increased, means that the magnitude also increased. So that the object just accelerate. It must be positive. Or for the second one, the velocity is directed to the right, still positive. Okay, but now please refer to the length of each vector here. It becomes shorter, isn't it? Means that the magnitude just decrease. Means that the object just slowing down, or it just decelerate. So for deceleration, the acceleration is negative lah, which is opposed to the motion. Next, for the third case, according to the direction of motion, which is to the left, so the velocity is negative because the velocity is directed to the left. But according to the magnitude, it just increases, isn't it? Based on its length lah, which is increased. Alright, so now we are talking about the magnitude which is increased. Then the acceleration is negative, which is directed to the left. And remember, acceleration also under vector. As long the object just accelerate, but it just directed to the left, so it must be negative. And lastly, the vector now, the velocity is directed to the left, still negative, but the magnitude just decrease, isn't it? Okay, decrease means that the object just decelerate, but remember, decelerate to the left, so it must be positive. Okay, so don't be confused. Positive A is not necessary to be accelerate. We need to check its direction. And also for negative A, it's not necessary to be decelerate. Alright, so we need to check its direction. Okay, I think that's all. So we just continue later by the next subtopic. Okay, thank you.